So we're going to take a look at marine reptiles, specifically some of their adaptations for the marine environment and what makes them unique or interesting in that respect. Reptiles in the marine environment tend to be pretty high up on the food chain, so their trophic levels are high. They feed on a lot of different types of organisms, and some of them are even top predators, like marine crocodiles and alligators. And some characteristics of these reptiles that are true of all reptiles, they all have an amniotic egg, and so that's basically an egg that's covered by a shell containing a liquid-filled sac called the amnion. And the amnion is going to be basically enclosing the baby within the shell, and that's distinct from, say, a fish egg, which does not have an amnion. Nor does it have a yolk, which is something we see here. An amniotic egg has a yolk that's going to sustain and provide nutrients for the baby during its growth and development. And an allantois, which is a waste sac. And so as the baby excretes waste, then the allantois collects it. And then the membrane surrounding all of this is called the chorion, and that's a membrane for gas exchange. So they're going to get oxygen across that membrane. And so if any of you guys eat eggs, like chicken eggs, for example, you can see all of these parts. The liquid-filled sac, the amnion, is on the inside of the membrane, the chorion. So if you peel a hard-boiled egg, for example, that membrane that comes off under the shell is the chorion. The egg white is that liquid-filled sac, the amnion inside, and of course the yolk is the yellow part that you're used to. And because those eggs have not been fertilized, they're not going to contain an allantois. So the eggs that you eat probably won't have that. So why have eggs? What's the adaptation that we're seeing here with marine reptiles? Why is this an advantage? Eggs basically allow for longer development of the baby. So we're talking about not having a free swimming larval stage, which is something we see in amphibians and fish, where they have a stage where they're small and vulnerable and swimming freely. With the egg, they're more protected longer. So they develop longer and they have that nice hard shell to protect them. Some other adaptations of reptiles in the marine environment: they have very advanced circulatory systems. They have really advanced and effective methods of oxygen supply delivery as well. And as far as tolerating the salt environment, their kidneys are very effective at elimination of waste, toxins, and anything in the water that could do them harm. Reptile skin is very scaly. It lacks glands, so these animals don't sweat. It's a method of preventing water loss for them. And something else that's important is all marine reptiles breathe air, not water. So even sea snakes, which we see in this picture right here, and we'll see more of them later, they have to come up for air. So marine reptiles all descended from a land ancestor, and so they are all air breathers with lungs. They are not water breathers. Marine crocodiles, we'll take a look at these guys. These include the American crocodile and the Nile crocodile. These guys go into salt water to feed. And this is another example of a crocodile. This is an Asian saltwater crocodile. So these guys can be extremely powerful swimmers. They can get pretty huge. Adult males can get up to even several thousand pounds in weight, 20 to 23 feet long. Females quite a bit smaller than that. These guys feed on fish, and sometimes they can even kill sharks that are their same size. So these are definitely an incredible predator, even when compared to a shark. They'll eat birds, turtles, snakes, land animals if necessary. Pretty much anything they can eat, they will eat. They usually hide in the water with only their eyes exposed when hunting. So you might have seen this if you've ever seen a crocodile sitting in the water. You usually see just its snout and its eyes. That's the only part out of the water. And what allows them to be so quick, even though they lay around all day resting, they're saving up their energy for quick bursts of speed so they can make very quick, controlled exertions and leap out at something and grab it very quickly. They're not endurance athletes. These guys are sprinters, so they can't go for very long that way. They'll usually start breeding between 10 and 12, older for males. Males can be very territorial and they will fight off other males for it. Females can lay between 40 and 60 eggs. They make little mud nests like this and they protect their eggs. And so these guys are actually kind of equilibrium species in some respects. Even though they're ectotherms, they do protect their young for quite a while, even once they've hatched. So the females, oftentimes they'll dig up the babies when they hear them chirping. The babies come out. They're kind of cute when they're little, aren't they? And a lot of the time the female will carry the babies around with her and raise them for a period of time. So the females are extremely protective of their babies, really, really good moms, and they will take really good care of those babies for quite a while. Crocodiles are actually very good at navigating, so if you take them away from their home location, they can actually travel back pretty easily. So that's kind of cool. Oops. Populations are doing okay as far as crocodiles are concerned, and their biggest threat is, of course, the destruction of their habitats. So now we'll look at sea turtles. Sea turtles, there's 7 species in the world's oceans that are exclusively marine. Sea turtles are typically tropical or warm water dwellers. It gets a little too cold for them, being ectotherms if they go up too far north or south. They're kind of a living fossil. They haven't evolved much recently, and so they're considered to be very similar to their ancestors. They do have a protective shell that's fused to the skeleton, and so they can't crawl out of their shell. It is attached to their skin, attached to their body. The shell has 2 layers. There's an outer shell with keratin, which is kind of a thin, flexible, protein-based layer. And then the inner layer of the shell has true bone, so it's calcified and it's firm and it's reinforced. Some terminology: the dorsal or the top surface of the shell is called the carapace, and the underside or the ventral part of the shell is called the plastron. And sometimes, not in this picture, but I'll show you some examples, some turtles have these little plates, like we see here with this green sea turtle, that make up the top of their shell, and those are known as scutes. Sea turtles have little vestigial claws on their forelimbs, on their flippers. Again, they also evolved from a land animal, a land reptile originally, and so they have the remnants of hands and claws. So that's a nice little sort of a shout out to their ancestors. That's a homologous characteristic that they have. They each have 2 fins in the back, 2 rear fins as their feet. There's a couple of interesting exceptions here. The leatherback turtle is an exception. It's the largest sea turtle that we know of. Has no shell, but instead has very thick skin with tiny bone plates. So this guy has basically like really thick back skin with little bones underneath the skin that give it a little bit more firmness. So that's an exception to this description that we've been providing here of a turtle. This allows the leatherback to be a little lighter, has a more streamlined body, and they're a little bit better in buoyancy. So that's an adaptation for that turtle. Sea turtles' heads do not actually retract into their shell. So that's unlike turtles that you see in ponds, freshwater turtles. Tortoises, land tortoises, are different in that respect. They can pull their heads into their shell. Sea turtles do not. Sea turtles are usually solitary. They only interact with each other for mating, so they're not group or social animals. When hanging out on beaches, they don't even interact with each other really. They're just doing their own thing. They tend to feed and rest quite a bit during the day, and so they actually will sleep either floating on the surface, or they'll actually go up on land or crawl on a rock and wedge themselves so that they can get some sleep. So this cute little green sea turtle there. As far as feeding goes, turtles do not have teeth. They have a very, very sharp beak. And most of them are carnivores. The green sea turtle actually is the only herbivore. He grazes on seagrass. But the rest of them will eat jellyfish. They'll eat fish if they can catch them, but usually they're too slow moving for that. So sea turtles are known for being jellyfish eaters. The leatherback, for example, has a digestive system that's tough enough to deal with even the most stinging or spicy jellyfish. To deal with salt, they have salt glands that are just above their eyes, and they sweat out or secrete concentrated salt that way. So again, they evolved from a land animal, so they're not totally equipped at dealing with salt. Breeding, they will actually mate at sea seasonally, and sometimes they'll only mate once every 1 to 5 years. And so their life cycles are very, very long. Males will court the females, they'll kind of nuzzle them, and then they'll mate. What's amazing about this is that after mating, the sperm can stay inside the female for several years before it fertilizes the eggs. And the reason for that is that The female may not be in the right place or time to actually lay her eggs. She may be way out at sea. It may be years before she gets back to her beach, which is where she goes, where she feels that she must lay her eggs. And so the sperm can be kind of like in waiting before actually fertilizing. It's pretty amazing. It can go on for years. Females will crawl up on the beach at night and lay their eggs. This is nighttime is where there's fewer predators around, and so they're a lot less vulnerable, and the eggs will be safer. They dig a pit in the sand and lay them, several at a time per nest, and then we'll cover them with a thick mucus layer to keep them moist before burying them. Each clutch can have 80 to 150 eggs, and they may lay several clutches within several weeks. So that is a lot of eggs and a lot of babies. So here's a female laying her eggs, and there's a clutch of eggs deep, deep down into the sand. Usually takes about 60 days of incubation, and the eggs during that time are very susceptible to predators. They could be eaten or taken or dug up. A lot of predators can dig and find those eggs, so it's very risky. They will hatch at night, and they will, as a group, dig out of their nests. So here's an example of some leatherbacks digging out of the sand, and there could be hundreds or thousands of baby sea turtles crawling up out of the sand on the beach. This is where things get really tough because they're really easy targets during this time. They're not very fast, and their only instinct is to beeline for the water as quickly as possible. And this statistic might blow your mind, but only 0.1% of hatchlings survive to be adults. So the mama lays so many eggs. This is very kind of an opportunistic approach. This is a great example of opportunistic species here. Sea turtles lay so many eggs because there's a very, very high probability that most of them will die. And they get plucked off the beach, or even if they make it to the water, they get eaten very quickly. So it's pretty amazing. Those that do survive to adulthood will migrate hundreds of miles from where they first hatched and from their feeding grounds. But like I said before, females will always return to the same beach where they hatched to lay their eggs. And this is where development of beaches has caused some major problems for sea turtles, because a female may have hatched at a beach, and years later, 5 years later, she returns to lay eggs there, and her beach has been covered by hotels, resorts, human activities that prevent her from laying her eggs there. So a lot of beaches, especially here in Florida, have been designated sea turtle nesting areas, and they're protected, and so they can't be developed. And it's really important for the survival of the species to keep those beaches safe for them. So it's pretty awesome. So scientists can actually track and monitor sea turtles to see how they're doing, where they're migrating, and basically what their statuses are as a species, as different species. So they'll stick this little transmitter to their top of their carapace, and that will transmit their location to a satellite. Receiving stations take it, and then a scientist would process that data and draw out some maps. And you can actually go to that, to cccturtle.org, and you can actually see where a lot of these turtles are being tracked. It's kind of cool. So again, most sea turtles are endangered, very sad. We'll be talking more about that later in this week, and so stay tuned for some of that. The last animal we'll talk about, marine iguanas. They're the only marine iguanas in the world, and they're in the Galapagos Islands. These guys are pretty awesome in their ability to tolerate salt. They are algae eaters and seaweed eaters mostly, so they're herbivores. And these guys will actually sneeze salt out of these nostrils, out of their nostrils, and their eyes. They will basically cry out salt, and so that's how they tolerate the salt that they take in their diet. So there they are grazing on algae. They come to the surface and they sneeze or cry out salt. They're really good swimmers. What's really cool is they change color when they're out of the water. They turn kind of a black. I'll go back up here. Dark color to absorb heat better, to get their body temperature back up to where it should be. When they're in the water, they're kind of a lighter color. They're red, they're green, they have a lot of different color patterns. And so that's a way of coping with cold temperatures, even though they are ectotherms. So they have to be very good at thermoregulating. Sorry, we had one more category here, sea snakes. There's about 65 species. We only see them in the Indian and Pacific Oceans. They stay close to shore, and again, they have to breathe air, and so they come up to the surface to breathe. A lot of them have venom, so some of them are dangerous, but most of the time they're actually pretty harmless to people, and they don't really mess with people that much either. What's neat is they can actually slow down their metabolism when they're underwater, and so that helps them to retain calories and retain body heat a little bit as they swim. It also makes them a little bit sluggish, so there's a trade-off there. Most of the time they'll eat fish and eels and then eggs of whatever they can find in the water. So anyway, that summarizes our reptiles. And